Hello, this is Jonathan Foote presenting a data-driven approach to bus timetable optimization recommendations. More data than ever before is being recorded about bus journeys every day throughout the UK. It is this data I have used to drive a search optimization algorithm for bus timetables based upon three main criteria. The first optimization target was to minimise the unneeded slack time at timing points and the travel times between every stop, while balancing the percentage of buses predicted to be on time. The second optimization criteria is to improve service cohesion between services at stops that are a part of a shared common route segment. A shared route segment is n consecutive stops shared by two or more services. As such, passengers will have no preference for which service they take, and will simply board upon whichever of the services arrives first at the stop. Therefore, it is more preferable to have these services more uniformly spread out and not to have all of them arriving in bunches. This involves identifying shared route segments within the network and then calculating new optimal target times for each service at the stop. The third optimization criteria is to minimize the total number of changes. Too many changes at once makes it difficult to be able to reliably predict how the timetable would likely behave in the real world. Here is the first screen of the program. It shows a list of all bus services operated by Reading buses built dynamically from the API using an MVVM approach. In the top right, the user can open a settings window. This lets them change program settings and different search parameters. To begin, the user selects a bus service to optimize for and selects a time region of interest for which they would like to generate a new timetable for the following year, as it is assumed that traffic and service demands levels will remain consistent between them. The program will then show them a list of different timetables that operated during this time period. The user can view these timetables and then decide for which of them they want to optimize for. Next, the program will display a list of services that share a common route segment with the primary service. The user can add or remove these services from the search as they wish. Finally, the program will download all of the historical data required for the search, before then showing the previous service's on-time arrival percentage. Here shows the search in action. The top right displays the iteration count, or the overall progress of the search. The top left shows the stage of the search algorithm. The progress bar shows the progress of the current stage and its sub-processes. The middle top centre of the screen shows the current score for the solution. The lower the value, the better the solution, and if the search is improving, a green up arrow is shown, and if it is worsening, a red down arrow is shown, along with for how long it has been non-improving. After completing the search, an overview of all moves made by the algorithm is shown, along with an explanation for which solution was chosen and by how much of a percentage it has improved by from the original. The newly optimized timetables are then also shown to the user. Here the user can highlight the timetables to see the changes that have been made, along with seeing the remaining problem areas of the solution based upon the objective criteria. Red areas indicate problem areas, whereas green areas indicate good areas of the timetable. The user can then click on specific timetable records to get more information about it, and can also export the timetable to CSV format to be used outside of the program.